Namaskar, Raj Krishna this side. Today we are going to solve problem based on Gauss forward difference formula. Now this is particularly the Gauss forward central difference formula. So we have two formulas. First one is Gauss forward central difference formula, and the second one is Gauss backward central difference formula. So we'll see it one by one. This time we are going to cover Gauss forward central difference formula. Okay. So here, as you can see, we have been given the x values, and corresponding to that the y values are given. You need to find the value of y when x is 3.75. Okay. So let's create the table. Table is created the same way as the difference table we used to make earlier. So let's make that. First of all, make some partition. So first difference, as we used to calculate earlier, the similar way, that will be, I will have to use calculator because the things are in decimal. So 22.043 minus 24.125 minus 2.082 minus 1.581 minus 1.382 minus 1.215. We don't have to write in middle because this is the first value. From the next onwards, we like to write this in the middle. Okay. So the second difference, this will be minus 1.818 plus 2.082 minus 1.581 plus 1.818 minus 1.382 plus 1.581 minus 1.215 plus 1.382. Third difference, right in the middle of these two, minus 0.038 fourth difference might be a bit boring because I tend to calculate each and every values myself. Minus 0. It's minus 0.032 plus 0.038. Last one, let me check it with the textbook that I have. So they have given different, I don't know why. Let's move on with these values only. Now According to question, if you see, because it's a forward Gauss forward central difference formula, and they are asking at x equals to 3.75. In forward, take just greater than, sorry, just smaller than, just do the opposite thing. In backward, take just greater than. So because it's a forward, that will be more clarified, because in case of forward, this is your p value lies between 0 and 1. In this case it lies between -1 and 0. Okay, so we'll see, but for that we need the x naught value. So what x naught value you must take, this is not a hard and fast rule that always you will get this type of scenario between 0 and 1. Whatever is given in the question, you have to follow that. So 3.75, just smaller than that, 3.5 you'll take at x naught. So this accordingly will become x power x minus 1, they denote it like this. This becomes x minus 2. Will go down, this is x1, this is x2, this is x3. Similarly, this becomes a y minus 2, y minus 1, this becomes y naught, y1, y2 and y3. Here we take the upper one, so y minus 1 and y minus 2, out of that write here y minus 2. Again 0 and minus 1, so take y minus 1, always take the upper one, then y0. Okay, this is delta, and delta y2. Again take the upper one, so delta 2 y minus 2, delta 2 y minus 1, delta 2 y0 and delta 2 y1. Okay, this is the case. Next, delta 3 y minus 2, delta 3 y minus 1 and delta 3 y0. Next, delta 4 y minus 2 and delta 4 y minus 1, and at last delta 5 y minus 2. Why I have written? Because if I write this, I don't need to think about making a central line or anything else, because as you can see, now I will come to the formula that I have for this Gauss forward difference formula which I have. So again that gives the value of y. Now interesting formula, y naught plus p, then you have what, delta y naught, and parallelly write the this is the Gauss forward central difference interpolation formula, and I will write the backward also so that you can compare, because in the same problem problem we can use both one. Slightly we'll have to change the x naught value, because as I told that in backward we take just greater than, so in case of backward you will take x naught as 4, and accordingly table this delta values will change. A table will remain as it is, but just the those values will shift a bit. So this is it. Now in case of forward, you write p first, p already there. Then in case of forward, write p minus 1 first. So p minus 1 and then p divided by 2 factorial, and minus 1 will come now twice, so first time we have taken this. Always write p after that negative, then again positive. P minus 1 p and then the positive one, which is p plus 1, 3 factorial, minus 1 will come again, so this. Then again p minus 2 will come first. So p minus 2, p minus 1, p plus 1. Down we will get 4 factorial, and now minus 2 will come twice. Again, because we have got values still, uh, wait, I have made some mistake. This will be third difference and this will be fourth difference. Okay, fine. Now what else we have got? We have got p minus 2, p minus 1, then p plus 1 and p plus 2, 5 factorial. And what we have got in table, you can see from the table itself that the next value is going to be delta 5 y minus 2. Fine, this much value we have got. Let's put the values. As I told parallelly, if you write the value for backward difference, it will be y naught, then p delta y minus 1, then again minus 1, then minus 2 and so on. There you will write p plus first, p plus 1, then p plus 1, p minus 1, then p plus 1, p plus 2, p minus 1, like this. Okay, so here your y will be y naught, which is 20.225, we haven't calculated p yet, so calculate it. P will be x, which is 3.75, minus x naught, which is 3.5, I guess. Yes, 3.5 divided by h, which is just the difference in x values, and which is 0.5. So if I calculate this value, I am going to get 3.75 minus 3.5 divided by 0.5. 0.5 we are getting, which lies between 0 and 1, and hence the forward difference. Okay, so 0.5 into the first one, which came out to be minus 1.581, plus p minus 1, that means 0.5 is what you have got, I think. 0.5 minus 1 is minus 0.5, 0.237 will be the next value. Then p minus 1, minus 0.038. Then p minus 2, p minus 1, p, p plus 1. Delta 4y minus 2 is minus 0.011. In the previous one, I just multiply by uh, minus 0 point. No, it will change. So minus 1.5 into minus 0.5 into 0.5 into 1.5 into 2.5 divided by 5 factorial, which is 120. 0.017. Let's carefully calculate the values, although I have taken a bit approximate values. 20.225 plus, although it's minus 0.5 into 1.581. Whatever result is obtained in that, minus minus minus, so minus 0.125, sorry, just I had minus sign, okay, because only this two is multiplied, 0.125 and 0.237. Result is there. In that, again minus 0.0625, sorry, a plus was there, because minus minus plus will be there. 0.038. Then again 0. With a minus sign I have 0.0234 multiplied by 0.011, and with that I have positive 0.0117, 0.017. I'm getting 19.4071, which is approximately matching with the one given in the textbook. So if I write y, this was 3.75 and this is 19.407. So approximately, if up to two decimal places they are asking, so I can write 19.41, correct up to two decimals. Okay. In textbook they have also given that if you calculate by Gauss backward, you have to take x naught as 4 and x is 3.75 as it is, then you will get some value in 19.40726, and then you can calculate the error, which will come out to be 0.0022. That is completely your task to do if you want. So with same problem you can calculate both forward and backward, but yes, for good accuracy it is always preferred that whenever you are taking p between 0 and 1, it is for forward, and whenever it is between minus 1 and 0, it is for backward. Okay, so that's it we saw today. Some special designs that you can see here is, you took the y naught value, then you go on to y minus 1, then to the, yes, in forward you go like this, down up. That is completely when you are not writing these values, then you have to check up down, that zigzag manner. But if you are writing these values, you will not be having any confusion, because you can directly see from the table that delta 2 y minus 2 is this, then you can copy and paste and get to your answer. So that's it from my side for today. You can watch more of this type of problem in the playlist, which is iterative techniques and interpolation.